Hello, this is Dan Garfield.
And I'm William Dennis.
Hopefully everybody can hear us. We're just going to get confirmation that the audio is working. If you could put in the little chat box or the questions and feedback, say, hey, we hear you loud and clear. Or if Mina's joined, she can tell us if she can hear us. But we'll give it just a second as people are joining here, and then we're going to get started. Pretty excited for this presentation today. William and I have worked quite a bit on this, and
yeah, we had like basically a sellout session at KubeCon. I think there were people like waiting in the wings. So.
It was standing room only, and there were people sitting on the floor. The fire marshal would not have been happy. Yeah.
And one of the fun things about this webinar is we can really talk about our own products too, and kind of some of the advantages.
Yeah, we'll actually go a little bit deeper than we went at KubeCon, so that should be good. I haven't seen any feedback yet from people saying that they can hear us.
Here we go.
Audio sounds good. Excellent. Mark has answered. Okay, good. Oh, wow. Now they're all coming in. Everybody's joining in. This is great, guys. Okay, cool. Well, thank you. We'll go ahead and get started then. So we're going to talk about basically how to do high velocity engineering and what that means and how people are doing that with Kubernetes. So a little bit of background here. Advance my slide. First thing, the place that we're coming from on this presentation is that we work with a lot of teams that are high velocity and have adopted Kubernetes successfully, and that's where we're taking that learning from.
Yeah, so I've worked with a few teams from eBay, New York Times, Philips, Niantic.
Yeah, Niantic is the team, of course, behind Pokemon Go. I know that may as well be Pogs at this point, but in terms of a huge scalability challenge, that was one that was very, very successful, and lots of teams have already adopted Kubernetes. They're using it in production. It's ready for prime time, and we find that people are able to actually engineer faster.
So why do teams choose Kubernetes in the first place? We've kind of identified 5 reasons here. One is scalability, so the ability to kind of go from like 1 node to 100 very, very quickly. As you said, Niantic with Pokemon Go is an extremely good success story there. I think their usage was something like 50x what they were predicting, and 5x kind of their worst case planning scenario. So, you know, proof there that with Kubernetes you can really scale. Avoiding downtime through the beautiful operator patterns in Kubernetes, the ability to like repair nodes and replace failing machines and crash containers is one of the big reasons. Cost reduction through things like bin packing, being able to like, you know, mingle a whole bunch of different services that could be quite diverse, like on the same pool of compute resources.
Now, we actually did, so these are kind of the common reasons that we think of. But William, you actually ran a survey to ask people why they were adopting Kubernetes, and I was surprised at what people chose because it wasn't scalability, it wasn't downtime, it was developer velocity.
Yeah, exactly. So this is a fairly unscientific survey, but in this customer advisory board that we ran, we kind of asked people like, well, what's the main reason for picking Kubernetes? And I was kind of expecting things like cost and scalability to really be the number one reason. Obviously, that were important reasons, but the number one reason for kind of 75% of the people that were there at the time was
business case for adopting Kubernetes, and they will be available for you to download and review, and you can send this presentation on to other people so they can watch it. But let's go ahead and, oops, why we got bumped off the screen share. There you go.
And so the final reason we kind of identified is the infrastructure abstraction. So this is definitely an important thing with Kubernetes. You know, you don't have to be thinking about machines and images or even which cloud you're running on.
Oh, they said they just lost audio. Hang on, it's coming back. Voice is lost. Yeah, we just got bumped. Audio stopped, now it's back. Okay, cool. So audio's back. All right, lost it for a short second. Basically, what we were saying is that these slides are great to use if you're trying to build a business case. Thanks, everybody, reporting that back. That's helpful. Okay, so let's move forward and why is high velocity so important? There are a couple of things that we really identified in these teams for why high velocity is a really key area of investment for them. We talk about high velocity, we're talking about a fast pace of change, right?
Right.
Fast pace of deployment. So number one reason we identified was reduced risk.
Yeah. So, the problem if you have like a quarterly release or even like a 2-week release is that you're bundling a lot of different changes up together and kind of pushing them all into production at once. So there's always the chance there that there'll be some bugs or some weird interactions between all the different features that are landing. And because there are so many things going in together, it can be hard to identify exactly like which one is actually broken.
Yeah, and so when you're making less risk, and then it's also very cost efficient. So if you think about changes that you're making as an engineering organization, the reason you're making those changes, the reason you're committing that code is because whatever you're making is going to provide value to the business, right? Usually through providing value to your customers. Anytime you spend storing that change and not deploying it is basically wasted money. You're basically paying an opportunity cost to not deploy those changes fast and start getting feedback on them, start getting the business value out of them that you expect. And then third, security. So a lot of people don't think of, they think of security and high velocity as antithetical, that they think that security and high velocity don't go together. It's actually the opposite. And I wrote a blog post recently where I introduced what I call Experian's law, which is that, when the data breach happened that Experian had, it wasn't because they shipped software that had a known vulnerability in it. It's because they had shipped software that at the time was considered secure, and then it sat there for about a year. And then it became insecure because vulnerabilities were discovered. So if you're doing these atomic commits, if you're used to deploying 5-6 times a day for each service, basically any engineer being able to push code and have it validated and pushed and deployed, then you actually become more secure because those dependencies are being updated automatically. All that stuff is happening in a very fast way. And if you need to respond to a change quickly, you can release quickly, and you have that mode of high velocity that allows you to not have new vulnerabilities be discovered. Because the fact is, you're already shipping software that has a vulnerability in it. You don't know about it yet. Nobody knows about it yet. And when it becomes apparent, then you can make that change quickly.
Yeah, and I guess just one final thing about the risk reduction. The real advantage of releasing so frequently is that you can identify issues very quickly too. Mm-hmm. So if with the atomic commits, if every commit is actually getting released, kind of like more or less like as an atomic feature, if you see a problem, it's pretty obvious. That generally that'd be the problem. You just roll that straight back and start again.
Yeah, and these if you do like a quarterly release and you've got like thousands of changes and you have an issue. Man, that's like a rat's nest to go figure out, whereas these atomic commits much easier to manage. So how do teams become high velocity? Well, there's some semi-obvious stuff. Obviously, everybody's super into agile. There's some discussion about microservices architecture and how you divide up your team, how you do better testing, those kinds of things. That's actually not the focus of this presentation. I think that there are lots of presentations on agile and its benefits, so we won't repeat that. Instead, we're going to talk about 5 things that we found in working with these high velocity teams. So we identified earlier a lot of basically large teams, large companies that are using Kubernetes. Some of those were actually startup teams as well. And we found that they all kind of have these 5 different best practices in common. And that's what we're going to run through. And I think this is where you're going to get a lot of the meat of this presentation and really good takeaways. So the first thing that we want to talk about is that high velocity teams center on images. And let me explain what this means. When you're working, let me read this quote from a software engineer. He says, "Our entire develop, test, stage, deploy cycle is Docker native. This reduces the complexity of each step, allowing us to build with a smaller team." Now, what does it mean to be centered on images? Basically, it means that your image is the star of the show. So if you think about it, when you create an image, it should be immutable. It should not change after you create it, and it should be ready to launch at any moment, right? It should have everything that it already needs. I talked to a team recently at a meetup. They came up afterwards and they said that they were asking about the ideal deploy flow. And they said, when we deploy, the first thing our Docker image does when it starts up is it downloads a WAR file. And I said, no, don't do that. That's awful. That's totally counter pattern. You want your image ready to go. When you hit start image, it should be ready to go. And if you step back for a second, you think about the old world. When you did a change, you really centered on the change set that you were delivering to production. With containers, you're not doing that anymore. You're centering on a container that you've created and how you get that to production. So it's a very different. So a container should be connected to every step of your process. It should be connected to a Jira ticket. It should be connected to whatever test validation that went in. It should be connected to deployment status. And a really good demonstration of this, I was working with a large, I can't say their name, a large video streaming company that you've heard of. And they're doing some machine learning. And what they do is they create images for each variant of their algorithm. And it basically acts like a petri dish that they get to maintain this sort of specimen of what they've created. And then they have everything attached to that image that they need to know about. So centering on the image is really key. And images transfer well.
Yeah. So I think like one of the real benefits of containerization in general is that you can actually you can potentially run the same container locally and in production. That means that if you have a bug in production and you want to try and reproduce that locally, you can actually just pull down that image, run it locally with your local configuration against like a test database, and hopefully reproduce that image. I was talking to a startup in Japan recently, and this was kind of like the biggest excitement when they were looking at adopting Kubernetes. And containers are like, so you're telling me like, if I can prove that it works locally, I have like a reasonably good assurance that it's going to work in production. That's where that immutability is really important. And we'll talk a little bit later about application portability and how to actually enable that.
Yeah, and a second point on that is if you have something that's in production and the container is not behaving as expected, rather than trying to reproduce it locally, what you can do is you can actually just pull that image down onto your local machine to reproduce it locally. And now you're working with the actual deployed entity rather than saying, well, I think that my code is synced. I think that it's on the right Git branch. I think that it should match. And this comes to the point of like, you don't actually necessarily need to SSH into the thing. Instead, you can just pull it down and use it and see what's going on. Just a point of order before I can move on to the next slide. This is being recorded, and it will be available for later viewing, and the slides will also be provided. And as you go through this, on your viewing screen, you have the option to leave feedback. And if you are enjoying the presentation, give us 5 stars. That helps other people find this later, and helps people discover this presentation. So going forward. The other thing about centering on images is that the images should carry a history with them. So that means that you're not using the latest tag to deploy. A very common practice for people is like, oh, what do I deploy to production? Latest. Well, that creates a problem because it basically makes it so you can't support time travel, what I call time travel, which is I want to go back to what I was using yesterday. And if you say, well, I'm running latest, I just deployed latest, now I want to go back to what I had previously deployed, that was also latest. Oh no, I overwrote latest, and now I've got myself into a problem.
When it comes to Kubernetes too, we're talking about the automation, and the automation just hates the latest tag, right? So like, if you have things like node auto repair happening, those processes are actually like, potentially recreating nodes that have failed. And if all you're specified is latest, you can actually end up with a situation where a Kubernetes deployment, which is kind of meant to have like a version, can be actually running multiple different images, which is really bad. So yeah, definitely drop the idea of using latest.
Yeah, and we'll show you how to do that. So this presentation, we're going through sort of the best practices here, and then we're going to get into the hands-on nitty-gritty. This is how you actually implement this kind of thing. It also should be closely coupled with Git. So if you create a new branch in Git, then your image name should reflect that. It should be linked to Git. You should be able to understand what commits created this image very quickly. And of course, you should be using automated builds. You should never be using local pushes. I'll hear people say sometimes, well, I want to build locally and then push my image up when I've got it ready. That's a bad idea, because if you're not using automation to build, then you don't actually know what's going to that image. You don't know if the code that they're working on has actually been committed to Git. And so you can potentially, create your own image, put it up into production, let people know they can use it, and then not actually carry through with committing those changes to Git. And all of a sudden people are wondering, well, what the heck, this thing should have these changes in it. I'm not seeing it in the code. And it's also security. I mean, that's a security concern for sure. You don't want people doing that. If their local machine was compromised, that could create issues. Whereas if they're going through the Git flow, all those things would be caught and prevented, and you wouldn't have any variance.
Yeah, I think this is really good to kind of protect against that accident of like having local changes that are not committed. You definitely want to make sure you're building off that clean environment, and using a CI system, doing an automated build, definitely kind of guarantees that. The other thing too is, as you said, it just means that every build is being done with the same environment, so you don't have that risk that environment variance is producing different images. So
yeah, precisely. Okay, so that's centered on image. The number two thing we found is that high velocity teams shift left. Now, a lot of people have heard this term shift left, and maybe they're unclear on what it means. We're going to explain it. Here's the quote to kind of demonstrate it from, this is Damon Zerkler. He was over at a company called Steelcase, which has a large IoT operation. They use basically thousands of images for all these different devices that they support, different services they work with. They said, when our engineers commit code, Codefresh runs all the testing we need and spins up an environment just for the feature they worked on. Our QA and design teams can access this unique environment and do a level of testing that just wasn't possible before. Our test cycle went from 3 days to 3 hours.
I think this has to be my favorite feature of Codefresh, actually. I love this.
I'm excited to show it later. So let me explain what this means. On the shift left side, this is typical dev release Git flow, where every time you make a change, you maybe go through unit tests, and then when you feel like you're done, you issue a pull request, you go through code review, and then it gets pushed into maybe a staging branch, where it's then finally pushed into an environment so that you can do integration testing, performance testing, manual testing, security testing, all those kinds of things. Now, the reason this isn't available earlier to the engineer is because they don't have an environment to work on. Now, this creates a big issue. This spot, this pull request spot, this staging spot becomes a bottleneck, where if you're working with lots of engineers, now you have to support lots of environments, or you're pushing all of these changes into the same environment. You're not working with something that's clean. You have to maintain that environment, and it is also very expensive from the code review standpoint. One of the most expensive steps in this process is actually when we do the code review. And so let's imagine a scenario here. You're an engineer. You're making changes, unit tests look good, you issue a pull request, you go through this code review, someone spends 30 minutes browsing your code, understanding it, making sure that it looks good. You push up into this integration testing environment, and it turns out it doesn't actually even work in the real world. It turns out maybe there's security vulnerabilities. Turns out it's not performant. And now they got to kick it back to the engineer to work on. And that guy that did the code review, the guy or gal that did the code review, of course, it just wasted a bunch of time on something that wasn't even ready for code review or a pull request. So when we say shift left, what we say is every time you make a change, let's do the integration testing, let's do the performance testing, let's do the security testing, let's do all that stuff, so that when they get to the pull request, the person who's looking at the code review can see that all these things have already passed. And if there are any issues, they were automatically kicked back to the engineer, so that only stuff that's ready to go is going to code review, and only stuff that's ready to go is getting pushed down this pipeline where other people are involved. And we found that when you can do this, not only can you develop faster, but you can also develop much cheaper, because making a change after something has gone into staging actually is very expensive because people are pulled out of their flow. People have to reopen something that they thought was complete. You may have issues where you've poisoned your Git history now with bad changes. All those things make it more expensive to change. So number 3, we found that high velocity teams maintain application portability. Explain what this means. Actually, William, how would you guys do this exercise at Google with disaster recovery you're telling me about?
Yeah, so we actually run these things they're called dirt tests, and you know, we'll create some kind of like funny situation, like the aliens have invaded and they've like taken out a data center or something, just to see how we can actually recover to these unforeseen events. How that applies here, and I think how you can kind of test to see have you defined your application well, is that if you can literally delete the entire namespace that your application is running in Kubernetes and bring it back with like a single command, if you can do that, it means that you've defined your application really well, right? Because that means that you've actually captured all of your application configurations separately to the actual cluster itself.
Yeah.
So it's kind of just a way of proving it. Now, I don't necessarily recommend actually going and wiping out production. So that's kind of just like a litmus test. You know, try a new staging environment or whatever. I mean, what you could do in production, I guess, is actually just, you know, pretend you wiped it out, right? Bring up an entirely new environment and then validate if that is actually equal to your production, and then potentially switch over to it.
Yeah, stand it up. Now, so raise your hand if you've heard of Helm, and then for all of you that raised your hand, laugh at yourself because you realize that we don't have a camera on you. We can't tell if you raised your hand. But if you've heard of Helm, Helm is a way of defining applications for Kubernetes where you have all of your services. So a typical example is you've got, you know, 75 different microservices. They all have different dependencies, and Helm basically is a package manager where you can say this is what my application is made of, and these are all of the different services that it relies on. Now, why is this super important? Well, obviously the use case where production is wiped out, that's important, but it also unlocks that shift left capability, because if you can bring up your application anytime, then you can do that full integration testing every time you make a change rather than having a specific environment for that. And you can use ephemeral environments, which means that you're not paying for them when they're not being used. So it's actually a cost savings thing on the infrastructure side as well. It also speeds up, I can't remember actually if the next slide talks about, okay. It also speeds up the onboarding process. So if you have new engineers coming onto the team and you say, well, here's the Helm package for the application that we're engineering, then they already have everything they need to start working. Whereas if you don't have that, then maybe they're digging around to try to figure out, well, this service interacts with some other service, but I don't know what service it interacts with. Setting up my environment may take a long time. Helm can actually simplify a lot of that. And we're going to show you some use cases for Helm in a minute that unlock even further possibilities, even outside of just the high velocity engineering kind of use case. So things to know, if you want to have that application portability, you shouldn't bake configuration into images.
Yeah, this is really critical to the kind of image first approach we were talking about before. If your database, like connection details, are baked into the image, then you're not going to be able to pull that container down and run it against a different environment. You're not going to be able to validate that image in your various different environments and promote that one image, which kind of breaks the model that we're proposing here. So, you know, make sure that that configuration isn't baked into the image.
Yeah, and so that you basically the image should be agnostic about the configuration of its external environment. So in order to solve that, I mean, if you're using the same image in test and production, that means you can't use oftentimes the configuration that's baked into images. Instead, you can use what would be external kind of configuration, which is Kubernetes has config maps, where you can basically define variables for a namespace or for an environment, so that when the image shows up, it can figure out what it's supposed to do, or how it's supposed to interact with the environment. And then, of course, you can set up secrets if you want to have things that are sensitive. And actually, Codefresh does a lot to help you manage config maps and secrets, not only in your cluster, but also just in the entire pipeline that I'll show you in a minute. Okay, so number 4. High velocity teams outsource cluster management.
So we think you should be focusing on building your application and not worrying about managing Kubernetes itself. It's likely your core competency. You have services and applications that you want to provide to your users. So the goal certainly at Google Cloud for a Google Kubernetes engine is to manage that for you. Let Google be your site reliability engineers, your SRE, and you can just focus on using Kubernetes and deploying things to Kubernetes, because there's already a lot of stuff for you to do there without you needing to worry about whether the etcd server is running, whether your nodes are healthy and things like that. Of course, some people may be choosing to run Kubernetes on-prem, which is great as well. For that kind of environment, what I often see is there's some internal team that sort of owns that and then provides this as a service to their other team. So however you do it, this is definitely I think a model for developer happiness. And make sure you have a plan for scalability and redundancy.
Yeah, and one other thing that I would say on that is that if raise your hand if you've changed a server rack recently. Again, I can't see you, but I'm assuming there are no hands being raised. That's because we figure out how to compartmentalize infrastructure from application development. It's the exact same thing with Kubernetes. You don't want your engineers running around fiddling with fixing a broken node or something. They should be worried about building their application.
So let me talk a little bit about why I think Google Kubernetes Engine GK is a really great place to run your clusters. So for one thing, Google has actually been running production workloads with containers for over 12 years. This was originally using our internal system called Borg. And in fact, we were developing with containers kind of for another 3 years before this, even contributing some of the original C group's code into Linux. And the key here is that we kind of looked at what we built, which was kind of like a bit of a monolith, and we took all the great lessons we learned and we built that into Kubernetes, and we continue to do that. So in fact, a lot of the team that I work with, a lot of the engineers that I work with in particular, actually come from our internal team that runs Google. And they're bringing all that experience and knowledge into Kubernetes and constantly building out the open source. And so what this means is that the same team that is bringing you Kubernetes engine are the engineers that are actually contributing to the development of Kubernetes itself. And I believe that we're currently the #1 contributor. So, you can be assured that the team that is bringing this managed solution really knows what they're talking about, both from, oftentimes actually running Google to also contributing to Kubernetes. And one of the things I love about Google Cloud and kind of makes me really proud to work on this is this quote here from Eric Brewer, really captures well, where he says, "We're going to be the open cloud, and we're going to give you the freedom to join and to leave, and I'll take my chances." And what I love about this is, not only the fact that I love open source, and this is like one of our VPs really saying just how valuable open source is to us, but this notion that we'll give you the freedom to leave, it's really going to keep us honest, right? If you can easily leave, we are compelled therefore to provide the best possible experience for you. And we're not using any there's no lock-in, so we're not taking advantage of that. It's that you're completely free to go. It's all open source. We're compelled to provide you constantly the best experience possible, and I think that's really
yeah. And one note on that: if you have application portability, then and you basically for instance, if you're using Helm and you're using the vanilla Kubernetes API, then you have that portability where, look, if I like this cloud or I don't like this cloud, I'm going to move and I can shift very quickly. I talked to a team who was looking at moving clouds, and for them it's an 18-month process, right? Because they don't have that portability, and they're tied into a lot of vendor lock-in kind of code. So by adopting Kubernetes, you actually get a lot of that flexibility, and you don't get into a situation where a cloud provider could potentially hold you over a barrel. Because it's like, look, it's going to cost you $14 million to change. So guess what? We're going to raise the prices by $13 million, and it's still cost effective for you. You can't do that with the Kubernetes world.
Yeah, and we're actually seeing a lot of really interesting use cases too that we really honestly support, and that's hybrid, where there's on-prem data centers. So a lot of people are coming at this, and they already have a data center, so or they already have some racks, and they don't want to just throw them away. They want to use them, through the end of life of that hardware. That's totally fine. Like you can actually connect that up into a hybrid situation.
Yeah, you can have failover from on-prem to cloud or vice versa.
Yeah, and then even multi-cloud too. So some people, it's the ultimate kind of redundancy. And that's all fine with us. Like that's why we're doing it. So okay, what does that actually mean for GKE though? So like like I said, we have a bunch of really smart engineers working on this stuff. What does that mean for you? What does that actually mean for your experience in GKE as an end user? Well, on this theme of outsourcing cluster management, I want to highlight just 3 points of GKE that are kind of my favorite 3 actually. And these all relate to automated operations. And when I say automated operations, I mean like stuff that you might have had to get that 3 a.m. phone call in the past that you don't anymore. And so the first one is cluster auto-scaling. Cluster auto-scaling will automatically add nodes to handle demand in times of like peak usage, and also scale back to save money in the downtime. I think both of these aspects are really important. If you're creating this, if you're pouring your energy into creating this product, you want to make sure that at that moment of success, at the moment where you're featured on some like high-profile news site or whatever, you want to be able to handle that demand, right? If you are turning people away at your moment of success, that success could turn into failure, and that's really scary. So cluster autoscaler is there to help you add capacity and handle that demand. But likewise, we don't want you spinning cycles and just wasting them, wasting your money, wasting environment. That's not why we're here. So we'll help you remove those nodes as well in the quiet periods and save money so you can reinvest that in your own products. Secondly is node auto repair. So node auto repair is a feature of GKE, which is constantly monitoring the nodes. It detects like various different conditions and will actually recreate that node if needed. It just helps keep your cluster up and running. So as long as you have more than a few nodes, that'll basically mean that, and as long as you have a few replicas of your pods and you've spread them well, this should actually mean that you can survive multiple node failures without any downtime. And finally, auto upgrade. You're talking about security earlier. Auto upgrade is really important. I think we all saw like the recent kind of CPU vulnerabilities. Things like auto upgrade mean that you can sleep soundly knowing that we'll actually like upgrade your nodes so that you don't have to worry about patching some of those things.
Yeah, there is a great blog post out a few weeks ago by I forget his name. He used to be one of the DevOps guys at Ticketmaster. He's at a new company, but he basically wrote and said, you should totally outsource cluster management because you simply can't keep up with the pace of Kubernetes innovation, which is, Kubernetes releases new versions typically quarterly. Is that kind of the schedule we're on?
Yeah, quarterly.
And if you're using something like GKE, it's going to automatically upgrade those nodes. You're not really going to have to worry about it, and it's just going to stay up to date with the latest features, latest security, all that stuff, and you don't have to mess with it. Yeah,
and I think like when it comes to security too, there's a lot more to security than just Kubernetes. You have to worry about the host architecture and the networking, and there's a lot of different facets. So yet another reason I think why outsourcing is the right move there. Google has hundreds of engineers just dedicated to looking at these problems, and we operate in like multiple different time zones as well, so you get like the coverage of the complete day.
Yeah, this is a sidebar, and I don't think you would plug. I'll plug this for you, William, so you don't have to. When there was the Spectre and it was Spectre and what was it?
Meltdown. Yeah.
Spectre and Meltdown happened. Google not only patched everything, but they actually did live migration of their VMs, so their users didn't have any downtime. They didn't have to restart anything, which is just, it like blows my mind, like how far we've come from the days when I built a server in my basement, 25 years ago.
Yeah, live migration is really cool actually. So yeah, it avoids that problem that you have to reboot the host OS for like a security patch. But actually, we've been like live migration. I just think it's one of the coolest things that like no one ever talks about because the other thing about live migration, right, is that we're actually looking at our VMs. And I don't know if you've heard of the noisy neighbor problem, but that's kind of where, you're sitting on a VM, you share it with someone else, and they're running like a database on it or something. They're just doing something that's just like hammering the IOPS and the network. And while, VMs and hypervisor, all that's meant to give you like isolation, does a pretty good job of it, it's not perfect, right? So we actually proactively monitor for conditions like that, and we'll even live migrate you for those conditions as well. So, not just when when there's a security patch, or when there's like some underlying infrastructure thing, like, we just have to get you off that machine because we need to like pull it out of circulation. But we'll even look for other conditions like noisy neighbor and use that opportunity to live migrate you.
Yeah, super cool.
Yeah, so one of the really exciting things about Google Cloud too is that, this was not an ordinary cloud. And, when we're looking at networking, we don't just use like off-the-shelf network switches. They just don't actually solve our needs. So we've actually created like this switch called the Jupyter switch, and you can read some research papers about this online if you're interested. But it's basically our own custom networking hardware, and there are multiple generations of that. We also build our own processing unit. So this is a photograph of a TensorFlow processing unit, a TPU, which actually I think went into beta just this week. So you can actually run machine learning jobs on this thing now. And so we're building our own switches because we just need to handle the sheer amount of traffic we're doing. We're building our own AI chips, and now we're even laying our own networking cables. So this is a photo here of a ship from the company that's actually laying one of Google's oceanic cables, which is pretty cool. All right, that's just some sort of tech stuff that I think is cool. But how does that actually help you? How does that help your container? Well, this is how. Because we've built this huge network of private fiber, and we've built this to handle loads like YouTube, which is like a crazy amount of traffic. Well, regardless of how much traffic your containers are doing, they're going to be running on the same network that was built to handle YouTube. What that means, and if you look at this map here and you see all those dots, those are all like points of presence and edge nodes. And so what that means is, and the lines are the Google-owned, or the Google contracted fiber. What that means is that the packet from your container is flowing over Google Fiber and then exiting at one of those nodes, likely very close to where your end user is. And this is, I just can't emphasize just how cool this is for both speed and reliability.
And security, right. Actually, on a third note. Yeah, the load balancer that's sitting in front of this network is actually another one of my favorite features. And though my mom is not impressed by it, I always like to tell her that her blog has the same load balancer as YouTube, which is just amazing. It blows my mind.
Yeah.
It's really, really cool, and it's way beyond something that you would get off of like, spinning up an EC2 with an elastic load balancer. It's a totally different situation. The load balancer that you get with Google Cloud is, frankly, it's overpowered, but I like that it's overpowered.
Yeah, so our load balancers don't run in VMs. We don't bring up a VM with like Nginx or whatever. And it literally is the same, like going through the same rule engine through the same front ends as YouTube and Google.com.
And if you're using GKE, don't you get the load balancer free? Like you're not paying extra for an extra node, basically.
There is a charge for load balancing, but yeah, all of the load balancing that you provision through Kubernetes objects is backed by a Google Cloud load balancer.
Yeah. Okay.
All right, so final point, on a kind of community-friendly note here, wherever you choose to host your Kubernetes, make sure it's certified Kubernetes. So as I said before, despite the fact that I think we have like a really cool place to run this stuff, we do honestly believe in portability, and we want to see Kubernetes adopted everywhere and give you that freedom to run everywhere and do these like hybrid and multi-cloud setups. So one thing to note though is that when you are evaluating different vendors for Kubernetes and specifically distributions and platforms of Kubernetes, look for the certified Kubernetes logo. This just means that their installation of Kubernetes has gone through a bunch of testing and has proven to be conformant. This is actually a program that we've been leading and we've put a lot of time in. Fortunately, it's pretty easy to find vendors that support this because practically every Kubernetes vendor does.
Yeah, so, and Codefresh actually works with any certified Kubernetes cluster out there.
Right. Yeah, and actually, I think from your perspective, it's really nice having this program because instead of you having to validate Codefresh against like everybody, you're just like, well, as long as it works with certified Kubernetes, it should be good to run.
Yeah, exactly.
Yeah.
Okay, so number 5, high velocity teams connect all the dots. And good reminder right here, as you have questions, go ahead and just put them in. we'll be monitoring those, and then we'll answer any questions at the end. But high velocity teams connect all the dots. What does that mean? Well, we talked about centering on images. We talked about having the Git flow. We talked about having this application portability. Now, if you're sitting there thinking like, gosh, it seems like it would be a ton of work to build all of the stuff to do this, well, I have good news for you, because this is actually what Codefresh is designed for. So Codefresh is, where's my screen here? Codefresh is basically 4 different components. We have these Kubernetes CI/CD pipelines that provide you Docker and Docker as a service. And I'll show that in a minute. And it's very, very powerful and allows you to basically do anything you need to do in a reproducible, reliable way, where you center on images, where you get kind of all this stuff that we've talked about. We also make it very easy to self-serve environments. Now, you can either automatically spin those up, or you can manually allow people to launch an application, which has a lot of implications both for the QA team, as well as for the sales team, as well as for product managers. And of course, in your automated testing, doing that shift left, you have to have that self-serve automated environment piece. Another component that's really key to Codefresh is release management. So if you want to spin up, update, roll back, monitor your applications deployed to Kubernetes, that's going to be very easy to do with Codefresh. And lastly, Docker and Helm registries are built into Codefresh, so you can store all of your images, put all that metadata there, so you can center it. And I'll show you what that means because it's demo time, and we're going to launch into this thing now. So just to reiterate, the 4 main components: the CI/CD pipelines, the release management, the image management, and of course, release management. Having all those things in one place. Now, I do see people try to back their way into this by building lots of scripts and cobbling together a bunch of different tools. But the fact is that with the pace of change that happens with Kubernetes and with Helm and with containers, it's very easy to spend way more money trying to build this yourself than you would otherwise use, and you lose a lot of time. So I actually talked to a team recently who spent the last 5 years basically developing these kinds of capabilities internally, but they don't have it for Kubernetes, and all of a sudden they're looking at re-architecting this whole thing, and it's like, we already built this. And we know what we did. We spread out the costs among all of our customers, so it's way cheaper. So let me show you what this looks like. Now, first thing I'm going to do here is I'm actually going to go into Google Cloud and just show what it looks like when you create a cluster. So I've got here, let me zoom in a little bit, and I apologize. Hopefully the keyboard sounds aren't too loud, but I'm inside of Google Cloud Platform, and I'm going to show you what it looks like to create a cluster in case you've never done this. We've got some Google Cloud credits coming at the end of this presentation that you can use. So to create a cluster, you just hit Create Cluster. The process is very easy and straightforward. You give it a name, demo cluster time. You can pick regions, give it a description. You can pick your zone, and Google Cloud has just a ton of zones available. You can keep it in Asia if you need to. I'm just going to use a single CPU, but you can go all the way up to these 96 CPU high memory behemoths for your clusters, and of course turn on auto scaling. I'm going to leave it on like that. You can pick your image. You can pick the size, number of nodes you want to have. I like to enable automatic node upgrades. I also like to enable node repair automatically because if something happens with the node, it will automatically basically provision a new one and kill the broken one. I'm going to keep legacy authorization here. I'm going to keep stack driver logging and monitoring, and then I actually want to turn on auto scaling right here. Now, auto scaling, this is a cool feature. Basically, what it will do, and I'll set the max size to 10. What it will do is when Kubernetes goes to schedule a new pod, if it finds that there's not enough room for that, it'll automatically add a node. And then when those aren't being used, then it will pull the old nodes down. So this is what William was talking about earlier.
And you can pair that with a horizontal pod autoscaler to actually automatically schedule new pods. The two things kind of work
yeah, they work together. Oops, no, actually, can't have negative. Okay. All right, so I'm going to go ahead and there are a couple of other options, but we're going to skip those, and I'll just go ahead and create that. Now, this process usually takes 2 or 3 minutes. We're going to skip that like a good baking show. We're going to skip the cluster creation process and go to one that we've already baked, this delicious Kubernetes pie. So this is one that I've already set up. It's called Helm Demo, and I was doing some work integrating with Artifactory for a demo, so I went ahead and named it that way. And you can see I've got a bunch of namespaces here. Right now, their statuses are all green. I can drill down onto that status, and I can see that I currently have an application deployed here, and I can see that its service, its deployment, its replica set, its pods, they're all up and running nicely. And I can also see the endpoint here, so I can actually open this, and I can see my application that I've set up here and make sure that it's running. Now, let's take when I talk about connecting all the dots, what do I mean? Well, let's go through a common use case here. Let's say that I have this application deployed, and I want to know what I currently have running in production. Well, I can actually see the image that's currently running, and if I click on that, it'll take me directly to a full image report with all of the information and history associated with this. So I can see who created it over here on the right-hand side. I can see when it was added to my built-in Codefresh registry. I can see the tags that it has on it. So in this case, it has, this is something I was talking about with your Git flow, having your images match your Git. You can see this one actually has the tag that's on it is for the branch name that it's on, and the number here at the end is actually the commit SHA. So you'll see it's 7658. Over here, you see it's 7658. So if I wanted to understand, what change went into this image, I can actually just click on the commit SHA, and this will take me directly into my version control where I can see a diff showing that basically I just deleted this line of text. So a very small change for that one.
This is really powerful, I think. Like just knowing exactly what code is running in the container is just super useful if you're trying to debug something.
Yeah, and of course we can also pull this image down to work with it from this built-in registry.
And you can pull the code. So you can get both. And
yeah, you can snag both. You can also see that I've added a couple of annotations here. One is a report to basically a security scan from X-ray. I've also have unit tests and quality checks. I have another one that actually has the Jira ticket automatically on here. Or I mentioned earlier that example of the large video provider, video streaming service that everybody's heard of, but I can't say their name, where when they do their machine learning, they actually put their kind of specimen ID on here and the specimen results for how this image performed when they ran. So like there are a lot of cool implications for how you can use this metadata and this extra information. I can get more information on this. For instance, I can see the entire process that went into creating this image, as well as exactly what happened when we rolled it out and how that process went. So I have all the logs available to me. And of course, if I wanted to optimize the size of these images, I actually get a report of the layers, and I can see which elements are actually taking up the most room, so I can take steps to optimize the image and actually make it smaller. So how did I get to this position? Well, first I started by adding a cluster. So I'm going to show you if I add a cluster here. You can see I've got support for lots of cluster providers. You can add your own if you've got a cluster running on your own servers or your own private cloud. You can see that I've actually added 2 clusters from Google Cloud. I'm going to trash this one. Get rid of that, and I can see all the nodes that are currently running there. If I add a new cluster, I can select, because I'm connected to GKE through my Google credentials. I can basically select the project and the cluster that I want to add, and it will be added to Codefresh and available for me to access through the pipeline. Now, one of the advantages of this is you don't really want all of your engineers to have kube control installed. You don't want to have all your engineers having access to Kubernetes. Instead, what you can do is you can basically set up that access through Codefresh, and then you have the control plane for how people interact with change management onto their clusters. So let me show you, we looked at the images, we looked at how you add a cluster. Let's go over and execute a build here. So I'm going to pull up my repositories. You can see I've got a bunch of different services here that I'm working with. All of these start with a Docker file because I'm just building those. And what I'm going to do, you can see I've got it set up to do an automated build on every trigger, on every commit. I could also do it on every pull request. You can see that I've got some encrypted secrets on this pipeline. And why don't I execute a change, and then we'll look at what it's doing, because it's going to take a minute or two to build. Clear this, and let's make a change here. And we're going to go ahead and just add some text to that. Everybody remembers you all remember what we were looking at earlier on this application. This is what it looks like. It says, let's chat. Let's add a little message here that says, let's chat. What should we say? It's Thursday. Anything special happened yesterday? Valentine's. Let's do Valentine's. Valentine's Day. Let's save that. We'll go ahead and commit it. Happy late Valentine's. Never want to be late for Valentine's, but it looks like we were, so we're going to go ahead and push that. Now we're going to see, this is going to, switch screens here. If we go and look at our builds here, we're going to see that it's already kicked off our happy late Valentine's Day build. Now, what is it going to do? When we talk about shifting left, this is essentially what we're executing here. In this case, it's going to build a Docker image. Now, one of the things that I've done here is on the tag, I've actually used the branch name combined with the commit SHA. And when I combine those two things, I get a unique tag that I can issue a rollback on at any time and have everything working, hunky-dory the way I want it to. I can also run my unit test here. In this case, I just need to execute a script that's going to run that, and then on success, it's going to set that metadata that we talked about. Now, if I'm using the command line, I can also manipulate the metadata from the Codefresh command line. Images, so I can pull all my images here really quick, which is actually going to be a really long list. And then if I wanted to add, some metadata, it's as simple as taking the ID and saying, Codefresh, annotate, blah, 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 with, tests. You get the idea. So I can do that. And then in this case, I have taken out the step to push this to Artifactory for this demo. And then I have my deploy my Helm package step. So what this is going to do, and this is actually really powerful, Codefresh has built-in steps for working with Helm. You can see here we basically pull an image to work with Helm. And we have the option to set environmental parameters here that are going to replace values in my Helm chart. Now, for those in the audience that have worked with Helm, you'll understand exactly what this is and how powerful it is. If you haven't worked with Helm before, this might be a little bit confusing, but basically I'm replacing values on the fly for my Kubernetes application, which is built up of 2 different services. I can specify that I want to deploy to my connected cluster, and all I have to do is pass the name, because the connection information is handled on the back end, and it's automatically going to be passed. You can see that I've specified the namespace. I've got an image pull secret here that uses the Codefresh built-in Docker registry, and I've set some other values here. Now, at the end, I actually package up this and deploy it into a Helm repository so I can reference this later. So if we go and look at our builds, this looks like it's completed happily. And if we go and refresh this, we will see that we have completed our 0 downtime upgrade. I can hear you all clapping inside, just going nuts, cheering, throwing confetti. Wow, it really works. Let me show you a few other scenarios here really quick. If I go over and look at Kubernetes, I can look at my Helm releases, and I can actually see the release that I just did. You can see that this release was modified a minute ago. And if we look at the history, we can see all of the releases I've already done. And if I wanted to revert back to my old version that I had earlier today, I can just issue a rollback using Helm, and it will go through and automatically change that image to the previous one. So we'll have everything we were looking for. So you can see here it's executing the rollback, pulling back to the previous state, running rollback. It was successful. Running freestyle. Rollbacks are nice. They go very, very quickly, and it looks like it is done. And if I refresh this, we're going to see. Go back up. If we go back and look at the releases here, we're going to be able to see that the rollback went ahead and executed for me. Just open this up. There we go. So now we can see that this rollback changed my image for me, and I no longer have that issue.
So I think one important thing to note, kind of some advanced reading, is setting up readiness checks. So the way Kubernetes does the rollouts, it's sort of like, as you said, it's like a 0 downtime rollout. But sometimes the container itself takes a little bit longer to actually become ready after it's booted. So a readiness check, which I'll just leave for you to research yourself. But readiness checks, yeah, really good for solving that problem.
Yeah. Now, on this history that we talked about, of course, you can actually see the elements that change in here. It will execute a diff for you. You can navigate the chart. You can see what values are being passed, and you can get a full manifest of this thing. Now, what does this mean in practice? Let me jump into a different account, and I'll show you a different example here, looking at this Helm charts. So this is one where on these images, you can actually see I've got my Jira ticket here. I've got a performance test associated with this image. So this one I've done a little bit more validation on. And if I go over and look at my Helm releases, and I look at the history here. Oh wait, I'm on the wrong account. Hang on. Let me go to this one. So one of the ways that people use this is we'll actually have QA people manually self-serve these things, as well as use them in an automated way. And if I go over to these Helm releases, you can see in this cluster I've got tons of different releases that I'm working with, and I can actually see in the history. I think these ones actually have more changes in them. I wanted to find a good example, but maybe I don't have one right now. I'll find another one later. Basically, people can interact with these, and let's see if this one has a good change history on it. Yeah, okay, so here you can see that you can see the differences that actually changed in this Helm chart. So in addition to tracking down the changes in an image, you can also track down the changes that went into your actual Helm chart with all of your services. And of course, we can connect external Helm repositories here, or private Helm repositories that then people can come in and install themselves. They can install them to any of the connected clusters and work with those. So pretty powerful stuff. Now, we are getting a couple of questions. So let's answer a few of these before we move on with the presentation. Somebody asked, I noticed that Codefresh has docs for JFrog bin tray, but I don't see any docs for Artifactory. Since both are JFrog's products, is the Artifactory setup basically the same as bin tray? Well, bin tray is specifically just for Docker images. So if you're using bin tray with Codefresh, then you're basically using it just like any other Docker registry. So I would basically, let me switch accounts again. I would basically go to my account settings. Now, I mentioned that Codefresh has a built-in Docker registry that you can use for free. There are, or no additional costs, I guess I should say. But there are lots of reasons that you might want to have multiple external registries. And here you can see that I have Bintray configured. Now, if you're working with Artifactory, I actually recommend using the Artifactory CLI. This is a step that I showed. I sort of glossed over it when we were doing this demo, but basically this step, this is actually a really good question to answer another thing here. So Codefresh's pipelines are built on the idea that every step is actually its own container that accesses a common volume. So what that means is that when I want to work with JFrog Artifactory, I actually just pull in an image that has the JFrog CLI installed, and then I can execute my commands against it. And it's very easy to work with, very easy to manipulate and add extra things. Oh gosh, we're almost out of time, and I didn't realize that BrightTalk would automatically cut us off. Let us skip forward
get to the code
just a little bit. Just to reiterate, image first, shift left, application portability, all these things. What we're really doing is Google Cloud is the best place, I think, to create and manage Kubernetes clusters, and Codefresh is the best way to manage your entire CI/CD workflow, your engineer's workflow, your DevOps workflow, basically your entire container lifecycle.
Yeah, absolutely.
We want you to come and try everything. So what we've done is we've created a code that's GCP Feb 18. And if you use this with Codefresh, what you'll get is $500 and up to $500 in Google Cloud credits and 10% off our Pro or Basic plans for 3 months.
This is really cool because I think a normal credits is just $300. So make sure you use this code and get the extra $200.
Okay, so let's cruise through these questions as fast as we can. Can you share a link for the CI/CD demo with Helm charts so we can do CI/CD demo? I will attempt to. I will try to follow up with you on that one. I noticed that. Oh wait, is it possible for Codefresh to create a unique endpoint ingress per SHA, something like maybe that can be used as a step in a larger pipeline? Yeah, so you can actually do more advanced things like that using this in the pipeline. And I would be very happy, reach out and go to our website and say request a demo, and we'd be very happy to show you how you could do something like that.
All right, and we are 10 seconds. So thank you everyone for joining us today.